Okay, ladies and joims, here we are. So we're not going to cover that much material. This is on, that was not a joke. Materials, we're going to cover materials, okay? We're going to start at page 146. We're going to go to page 154. That's it. Okay. And I'm just going to read this and go through it with you. In the real world, each object reacts differently to light. Steel objects are often shinier than clay vase, for example. Wooden container does not react the same to light as a steel container. Each object also responds differently to specular highlights. Some objects reflect the light without too much scattering, resulting in small highlights. Others scatter a lot, giving the highlight a larger radius. If we want to simulate several types of objects in OpenGL, we have to define material properties specific to each object. Okay. In the previous tutorial, we specified an object and light color to define the visual output of the object, combined with an ambient and specular intensity component. When describing objects, we can define a material color for each of the three lighting components: ambient, diffuse, and specular lighting. By specifying a color for each of the components, we have fine-grained control over the color output of the object. Now add a shininess component to those three colors, and we have all the material properties we need. Apparently. In the Fragment Shader, we create a structure to store the material properties of the object. We can also store them as individual uniform values, but storing them as a structure keeps it more organized. We first define the layout of the structure, and then simply declare a uniform variable with the newly created structure as its type. Okay, and that would obviously be in the... Oh, actually, where are we at? In the Fragment Shader. So is that in here? Okay, there we go. So we just took that and put it in the Fragment Shader. Excuse me, I burp on here. Okay. Burped right in the audience's eardrums. Alright, as you can see, we define a color vector for each of the Fong lighting components. The ambient material vector defines what color the object reflects in, and that is the same as the object color. Diffuse material color. Diffuse lighting, the diffuse color is just like ambient lighting. The specular material vector has the uneven reflection of the highlight color. Lastly, the shininess impacts the scattering radius of the specular highlight. Okay. With these four components that define an object's material, we can simulate many real-world materials. Really? A table, as found at devernay.free.fr, shows several material properties that simulate real materials found in the outside world. The following image shows the effects several of these real-world materials have on our cube. As you can see, by correctly specifying the material properties of an object, it seems to change the perception we have of the object. The effects are clearly noticeable, but for the most realistic results we will eventually need more complicated shapes than a cube. In the following tutorial sections we will discuss more complicated shapes. Oh, whoa, look at that. Oh, that's cool. Really? OpenGL, multiply the shininess by 128. Bum, bada boom boom. Interesting. Huh. Cool. Okay. Actually, let's just for safekeepings, let's put that in favorites, OpenGL. There. There, that's cool. As you can see, by correctly specifying the materials properties, okay, getting the right materials for an object is a difficult feat that mostly requires experimentation and a lot of experience. So it's not that uncommon to completely destroy the visual quality of an object by a misplaced material. Let's try implementing such a material system in the shaders. Okay. Here we go. Roll up your shader materials sleeves because we're going in. We created a uniform material structure in the Fragment Shader. So next we want to change the lighting calculations to comply with the new material properties. Since all the material variables are stored in a structure, we can access them from the material uniform. Right, so let's put it all in material dot whatever. That's okay. So the first one, ambient equals light color times material.ambient. Really? So we're going to just take this out. So we take that one out. Wow. Yeah. Coolness. Okay, so vector 3 norm equals normalize, light dir equals that, of course, and then differential, different, and then right here. And I'm wondering if I really need to put these in the right order. Okay, specular strength we won't need. Excuse me. Whew. Okay, view dir equals normalize view there. Okay, light. Okay. This and then what? Oh. This part becomes a little different because you're actually putting okay, specular. Oh yeah, so we're not even timesing by the interesting. Of course, that makes sense, I guess. I suppose. Okay. As you can see, we now access all of the material structures properties wherever we need them, and this time calculate the resulting output color with the help of the material's colors. Each of the object's material attributes are multiplied with their respective lighting components. We can set the material of the object. Hold on, I gotta take off my shoes. Hold on, hold the phone. There we go. And the second shoe is off. There we go. Comfort has come to my feet at last, at long last. Okay, setting the appropriate uniform. Okay, a structure in GLSL, however, is not special. It is not special in any regard when setting uniforms. A structure only acts as an encapsulation of uniform variables. So if we want to fill the structure, we still have to set the individual uniforms. But, oh, that's interesting. So the structure is nothing special. Okay. But this time prefixed with the structure's name. So now we're going to go into the actual program. Oh, shoot. Right here. Change all this stuff up. All that stuff. Not right there. Oh, wait. Is it right there? I don't know. Where's it at? Ambient location, diffuse, specular, shine. Location. Ambient. Are we going to use any of this stuff still? Do we have to use any of this? Should we use any of this? The object, color, light position, view position. Is any of that stuff still valid now? Or I don't think we're using these. We're using the light position, but we're not using the object color or the light color. Or wait, right there. Oh shoot, what? Okay, I am confused. Are we just adding these in? We're just adding these in. As structural access encapsulation of the uniform variables, we're going to fill the structure we have the individual uniforms. It's time to prefix with the structure's name. Okay, we set the ambient diffuse component to the color we like the object. Component will keep the shyness of 30 degrees influence. Run the program. Give something similar like this. Really. So where does this go? Where does this go? Just anywheres in here. All right, let's just put it in here somewhere. I don't know where. I don't care where. Huh? Why did it do that? Why did it do that when I clearly did not want it to do that? Why did it clearly do that when I did not want it to do that? Why? Why? Ask why. Why am I skeptical? Run the program now. Okay, and these are driving me wild. What are these? 160. Conversion from double to GL float. So you know what? You just come over here. That's it. Okay, can we take that out of there? And what's the other one? 270. Equals conversion from double to GL float. Okay, you know what? Just the same thing. Do we have to do this? Really? Okay. There's that and that. 275, same thing. I tell you. 278 and 9. Okay. 286. That was a good processor in its time. Argument, conversion from double to GL float, possible loss of data. Alright, are we done? Are we done? Conversion from double to float. You know what? Where? Oh, where? Oh, right there, right there. Okay, are we done casting? Hey, good. See, there's a lot less errors and warnings. I just, get a little bit OCD about that. And now we've lost it, ladies and gentlemen. We've lost it. The fragment shader is not compiling. We're definitely in trouble. So we broke the fragment shader, just a little bit. Just a tiny little itsy bitsy bit, It doesn't look right. Mine doesn't work at all. So where's the fragment shader? Can I get a copy of that? It's not going to show me, is it? Oh, fragment shader here. Okay, good. Show me. Show me the fragments. Oh, and you put in a light thing? Oh, that's cool. Why did you do that? That's cool. Well, I missed that. Gotta go back up and put in the light thing, but I don't know. Alright, let's look at this again. Ambient. Okay, material, right? Okay. So that looks good. I don't know why that's a problem in normal. We're using light color, light position, view position. I don't see object color in there. I really don't. I don't think we're using it. So, but anyways, look at this. Normal equals normalized normal. Light dir equals normalized light position minus fragment position. Difference equals max dot norm light dir 0. Diffuse equals light color times diff times material dot diffuse. Diffuse. Specular. View dir normalized. View position fragment position. I don't see anything wrong. You guys see anything wrong? Max dot view dir reflect dir 0 0 material shininess. Huh. I don't get it. We set the ambient if you don't go to the color like object. Did I mess up here with something or? Could it be right here? Could this be it? There's a space there. Spacey. Nope. Okay, Fragment Shader failed to compile with the following errors. Error 030, number 143, undeclared identifier light color. One compilation error. Light color is a undeclared identifier. Light color. Why would that be an undeclared identifier? Tell me now. Tell me now. So light color, it's right up here. It's a thing. It's in there. Lighting shader.use goes through all this junk, goes to the light color there. Everything's fine, and it won't compile the shader. For some reason, convoluted reason, I don't know. I'm unsure, Nater. So where is, I don't, if this was working fine, and then all of a sudden, okay, I'll pull it together here. We're in 18 minutes, we gotta figure this out. What can we do? The light color is not good. Try a different color. No. Okay, so in, vector, out, color, uniform. Well, alright, let's look at the other fragment shader for crying out loud. So we're going to leave out this light thing, which gets put in later. Okay. Okay. Everything gets changed again, so I can't compare. Everything gets changed again, so I cannot compare. This is not fair. This is not fair. I'm telling you, it's not fair. Alright, hold on. Darn it. Damn it, Jim. I'm a programmer, not a doctor. So they changed light ambient times material ambient. So that'll be just, what, light ambient, right? That's fine. There's nothing wrong with that. Okay. And then down here you get, the light position. So instead of light position, it's light dot position. Okay. So big deal there. Whoop whoop. Here it is light diffuse instead of light color right here. Light color times diff times material dot diffuse. Why is this undefined or whatever? Oh, Oh, wait a minute, right there. Did you see that? Oh my God, I just caught it. It's a small case C. If I could say the F word. Oh my God, and it works. Would you look at that? And now you can see it. Hold on. How do you go down here? Let's go down and look up. Go down to look up. See, look at that. Now it's working. Okay, cool, cool. All right, so then let that be a lesson to you. Anything that's like a lowercase, okay, when it should be an uppercase, check it, check it, check it. Okay, so that took way longer than I thought, and so we're going to keep going. We're up to 20 minutes, but we're fine. Okay, okay. If it's something like that, yes, I looked at it. It doesn't look really right, though, right? Okay. Light properties. How far are we? We're only a few pages away. The object is way too bright. The reason for the object being too bright is that the ambient, diffuse, and specular colors are reflected with full force from any light source. Bada boom, bada bing. Light sources also have different intensities for their ambient, diffuse, and specular components, respectively. In the previous tutorial, we solved this by varying the ambient and specular intensities with a strength value. We want to do something similar, but this time by specifying intensity vectors for each of the each of the lighting components. If we'd visualize light color as vector 3, 1, the code would look like this. So each material property of the object is returned with full intensity for each of the light's components. These vector 3, 1 values can be influenced individually as well. Just so you know, this is a vector 3 where all the components are 1. Right now, the ambient component of the object is fully influencing the color of the cube, but the ambient component shouldn't really have such a big impact on the final color. So we can restrict the ambient color by setting the light's ambient intensity to a lower value. We can influence the diffuse and specular intensity of the light source in the same way. This is closely similar to what we did in the previous tutorial. You could say we already created some light properties to influence each lighting component individually. We'll want to create something similar to the material structure for the light properties, right, which I saw earlier and I was kind of mad about, but not that mad. Okay, light. Okay. A light source has a different intensity for its ambient, diffuse, and specular light, and apparently so does the material. The ambient light is usually set to a low intensity because we don't want the ambient color to be too dominant. The diffuse component of a light source is usually set to the exact color we'd like a light to have, often a bright white color. Oh, signaling the afterlife in heaven as you're floating away. Go into the light. Okay, the specular component is usually kept at vector 3, 1, shining at full intensity. Note that we also added the light's position vector to the structure. Nice. So there's no shininess in this light, but there is a position. That makes sense. Just like with the material uniform, we need to update the fragment shader. Nice. So from the last one, we took out this object color. Okay, now we're going to take out the light color and the light position. Am I right? The object color, gone. The light position, gone. I don't know if the light color is gone yet, but we'll see. Okay, so ambient equals light dot ambient. Oh, right, so instead of being the same thing each time, so that's gone. All right, normalize, diffuse equals Yeah, I'm being more quiet now. Specular equals. This is cool. This is really cool. Okay. We then want to set the light intensities in the application. Oh gosh, more? Really? Really? So do we even use this view position still? Yes, and everything. Okay. So, yeah. Boom, 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 boom. Let's move this up with the uniforms. Move that in with the ins. Just because I'm OCD. Okay. That looks good. That looks terrific. It looks terrific. Now, what's all this? What's all this? So we then want to set the light intensities in the application. Light ambient location equals get uniform location, light ambient, light diffuse. Oh, I see. Right. So we're creating a location, or we're getting the location from the uniform or from the shader, and then we're assigning these values to it, which would be right in here. So we don't need object color, light position. Yeah. We don't use these anymore. Object color, light color. Let's just, instead of deleting them, let's just, comment them out at the moment. So light position, object color, light color. There. Okay. Oh, and then this we have to do our little thing. Bing. Prom. I'm telling you. Let's darken the light a bit of the scene. Oh, that's a nice little commented out command, isn't it? In it? Okay, now that we modulated how the light influences all the object's materials, we get a visual output that looks much like the output from the previous tutorial. This time, however, we got full control over the lighting and the material of the object. Changing the visual. Let's spice things up a bit. Okay, so compile. Are you telling me? Are you telling me to compile? Okay. Nope, something's wrong. It's got errors. Line 143, light position. What the heck? Is this in the fragment shader? Line what? 31 actually. But what is it talking about? Oh, right. Well, that's not going to be POS. It's going to be dot position, right? Isn't that right up here, dot position? Okay, great. So now try it again. No, something's still not right. Is it? Yeah, something's not right. View position, ambient. Oh, right. Why are there all these spaces in here? I don't get it. How do I see these things? See, now it works. How do I see these things and make changes? I don't know. So how can I get the light in the picture there? I want to see. It's not showing, but I can imagine that would be something. Okay. Interesting. That's an interesting little effect. It's called getting too close to the object. Okay. Anyways, yeah. So actually, wait a minute. When does it set the light in the position? Did I miss something? I think I missed something. Alright, hold on. Hold on. Okay, I want to look at the fragment shader for a second. Now that we're there. Yeah, and that's, yeah, so. And then the actual code. Hold on, let me look at the code too. Doubly cheating here. You can find the application source code here. Okay. Shows you how to do this too. You guys can go in and look at the code for these. Of course. Lighting shader, light position. Where's it at? Come on. Come on. Light position. It didn't tell me to put that in. It did not tell me to put that in. Seriously. Didn't tell me to put that in. I'm putting it in. See? Light position. Told me to take it out. Okay. So light position location equals light dot position. Light position location dot dot dot. That makes sense now. So that was why, because the light, for some reason, I mean, actually, the object was in place, but the light for the calculations was not in position, so now it is. I wondered why something was up. Something was up, folks. Something was up, and I could tell. Jeffy knows. Jeffy knows when things are wrong with computers. Okay, yes, that was a nerd gasp. Okay. As you can see, a different color light greatly influences. Yeah, okay. So far we use light colors to only vary the intensity of their individual components by choosing colors that range from white to gray to black, not affecting the actual colors of the object, only its intensity. Since we now have easy access to the light's properties, we can change their colors over time to get some really interesting effects. Oh, that's cool. Since everything is already set up in the fragment shader, changing the light's colors is easy and immediately creates some funky effects. As you can see, a different light color greatly influences the object's color output, since the light color directly influences what colors the object can reflect. As you might remember from the colors tutorial, that has a significant impact on the visual output. We can easily change the light's colors over time by changing the light's ambient and diffuse colors via sine and glfw get time. Right, okay, so diffuse color, ambient color. Oh, huh. So light color, and where does this go? Well, obviously, it goes in the main loop. Okay, like up here. Right, there's more. There's more here, folks. We've got structure. Oh, do I have to do this after the fact? Light, color, time, get time. So let's just take this out of there. Put it down here. Okay. Oh, now we got a whole bunch more of these little equals conversion. 3 in a row. 192. Whoops. And there's an actual. Okay, I'm guessing it's all right here. This is probably a double, so we'll just GL float it. We're going to GL float it. All 3 of them. There we go. Oh, wow. That's cool in Nature. Oh, that's cool in Nature. Dude. Bro. Bro, dude. Dude, bro. See, now this is really cool because we're facing directly towards the light. And so, yes, yes, look into the light. That is so cool. Okay, that's cool. I like that. I like that. Okay, and now we're down to the exercises, and I'm not going to do those just yet. I'm going to come back later and review stuff. Lighting maps. Sounds interesting. Use the maps to find your way. Okay. All right, see you next time on the next video. Might be tonight. I don't know.